Good afternoon, everyone. Okay, so today we are going to discuss in states of matter liquids. Already we have completed gaseous state. So in gaseous state, you have studied that there are 11 gases. There are altogether 11 gases which exist in the elements which exist in gaseous state are all noble gases: hydrogen, oxygen, nitrogen, fluorine, chlorine. So altogether there are elements, 11 elements which exist in gaseous state, 2 liquids and all are solids. So after that we have discussed what are the properties of gases, gas properties, then we have discussed different gas laws, Boyle's law, Charles law, Gay-Lussac's law, Avogadro's law, ideal gas equation. Then we have discussed ideal gas equation, why deviate real gases ಅಂದ್ರೆ ಏನು, ideal gases ಅಂದ್ರೆ ಏನು, why real gases deviate from ideal gas equation. So ಅದನ್ನ ಕರೆಕ್ಷನ್ ಮಾಡೋದಕ್ಕೆ another equation was there, that is van der Waals equation. Then you have studied compressibility factor, Z factor, right? Then also we have studied kinetic theory of gases, postulates of kinetic theory of gases. So with this we have completed gases. Next is liquid. A liquid so what is liquid? Definition of liquids. So solids and linear solids means intermolecular force of attraction is stronger in solids. Intermolecular force of attraction is stronger in liquidally. Intermolecular forces of attraction is moderate in gases. Intermolecular force of attraction is very free moving. Okay, so gas, solid, liquid and gases. Intermolecular force of attraction in solid is greater. Intermolecular forces antandre the attraction between two molecules. These two molecules, intermolecular force of attraction is stronger here. Here it is moderate, whereas here it is less intermolecular force of attraction. Okay, so solids have definite shape and volume. Liquid have definite volume, no definite shape. Gases have no definite shape, no definite volume. No definite shape, no definite volume. No volume, no shape. Here liquids have definite shape, definite volume. Volume is there, shape, volume is there, shape, no definite shape. Whereas in the solids, definite volume, definite shape. Definite volume, definite shape. Okay, so this was the explanation for solid, liquid and gases. All three states are interconvertible. You can convert from one form to another. So next is liquid. First of all, what do you mean by liquid? Liquid and what are liquids? Liquids means those in which intermolecular force of attraction, molecules are held together by intermolecular force of attraction. Intermolecular force of attraction in liquids are greater than gases, but smaller than solids. Solids are intermolecular forces of attractions are greater. Then comes solids are ಜಾಸ್ತಿ ಇರುತ್ತೆ, then liquids, then gases. Intermolecular force of attraction. Okay, intermolecular force of attraction in solids is greater. Solids are ಜಾಸ್ತಿ ಇರುತ್ತೆ, liquids and gases. So what are liquids? Liquids are the it is a state of matter in which intermolecular force of attraction is less than gas. I mean, it is greater than gas but less than solids. Greater than gas but less than solids. Intermolecular force of attraction is greater than gas, less than solid. Okay, first point. Second, ಅಂತಂದ್ರೆ liquids have definite volume, no definite shape. They have definite volumes but does not have definite shape. Then liquids have kind of properties. Some of the important properties of liquids. Properties of liquids are, first one, vapor pressure. Vapor pressure. Second, surface tension. Surface tension. Surface tension. Third one, viscosity. Viscosity. Vapor pressure, surface tension, viscosity. So these are some of the properties of liquid. Okay, so liquids, what are liquids? Liquids are those in which intermolecular force of attraction is greater than gases but lesser than solid. Liquids have a definite volume but no definite shape. Okay, properties of liquid. What are the properties of liquid? Some of the properties, important properties of liquid are vapor pressure, surface tension and viscosity. So let us discuss each property in detail. So last concept, states of matter is the last concept. Vapor, liquids complete ಆದ್ಮೇಲೆ properties of liquids we are going to discuss. Vapor pressure, surface tension, viscosity. You ಮೂರನ್ನು discuss ಮಾಡ್ತೀವಿ. Definition ಏನು, unit ಏನು. After this we are going to discuss liquefaction of gases. Gases ಅನ್ನು liquid ಆಗಿ ಹೆಂಗೆ convert ಮಾಡೋದು, liquefaction of gases. After that, states of matter will be completed. Probably by tomorrow we are going to complete states of matter. First one, first property, vapor pressure. Vapor pressure. Vapor pressure means what? So vapor pressure, it is the pressure exerted. It is the pressure exerted pressure exerted by the liquid, pressure exerted by the liquid on surface of liquid, on the surface of liquid. For example, see here. So if you take, this is a liquid here. The water or any liquid, if you take the liquid here. Okay, this is liquid. This is outer atmosphere, outside, outer surrounding. So this is a surface, interface between atmosphere, surrounding and liquid. Is a liquid. Okay, you can see this is liquid and this is called as interface, surface, interface, surface. Okay, so whatever water vapor you have vapors are existed, vapor irutte. So these vapor which exert pressure, vapors, the pressure exerted by the liquid on the surface of liquid is called as vapor pressure. If vapors are this vapor put some force, apply some force on the surface of the liquid. This liquid, for example, let us take this is water and this is water vapor. This water vapor. Okay, this is neer, that is the vapor. ನೀರು ಮತ್ತೆ ಅದರದ್ದು ವೇಪರ್ ಆವಿ. ಸೊ ಇದು ಎರಡು ಏನಿರುತ್ತೆ, ದೇ ಆರ್ ಬೋತ್ ಆರ್ ಇನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಬೋತ್ ಆರ್ ಇನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಸೊ ದೀಸ್ ವೇಪರ್, ಈ ವೇಪರ್ ಏನ್ ಮಾಡುತ್ತೆ, ಎಕ್ಸರ್ಟ್ ಸಮ್ ಪ್ರೆಷರ್, ಪ್ರೆಷರ್ ನ ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಪ್ರೆಷರ್ ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಆನ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ದೇ ಎಕ್ಸರ್ಟ್ some kind of pressure, and this is called as vapor pressure. It is called as vapor pressure. So what is vapor pressure? The pressure exerted by the liquid on the surface of the liquid is called as the vapor. The pressure exerted by the vapors. Sorry, the pressure exerted by the vapors are regulated by the vapors. The pressure exerted by the vapors on the surface of liquid is called as vapor pressure. It is also called as saturated vapor pressure. It is also called as saturated vapor pressure. Okay, see here, this is a liquid and this is a vapor, water and its vapor. These vapor exert some pressure, put some pressure on the surface of the liquid. These vapor are in equilibrium with this water. Both are in equilibrium. Both are in equilibrium. Both are balanced. So this is called as vapor pressure, or it is also called as saturated vapor pressure. So what happens if you heating, on heating what happens? What happens on heating? When you heat this, when you put, when you heat this, what happens? Vapor pressure. On heating, vapor pressure increases, number of vapors increases, vapors ಜಾಸ್ತಿ ಆಗುತ್ತೆ. heat ಮಾಡಿದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ, liquid ಇದ್ದಿದ್ದು vapor convert ಆಗುತ್ತೆ, liquid ಇದ್ದಿದ್ದು vapor convert ಆಗುತ್ತೆ, number of vapor increases. So on heating, vapor pressure increases. On heating, vapor pressure increases. Why increases? When you heat, when you are heating, when you are boiling, number of vapors increases. So thereby vapor pressure increases. And the temperature, this is very important points here. The temperature at which vapor pressure ಏನಿರುತ್ತ, vapor pressure of liquid becomes equal to atmospheric pressure. Atmospherally pressure irutte, atmospheric pressure. When both are equal, vapor pressure is equal to atmospheric pressure. Vapor pressure is equal to atmospheric pressure. Vapor pressure atmospheric pressure ಎರಡು ಸೇಮ್ ಆದಾಗ what happens? The liquid will boil. Okay, and this is called as boiling point. Of liquid. Okay, so what is the boiling point of liquid? Once again, on heating, vapor pressure increases. Heat ಮಾಡಿದಾಗ vapor pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ obviously. The temperature at which, so when you heat this, vapor pressure increases, number of vapors increases, so thereby vapor pressure increases. So the temperature at which vapor pressure, the pressure due to vapor becomes equal to atmospheric pressure. Atmospheric pressure irutte. Atmospheric pressure, what is that? Atmospheric pressure is 1 bar pressure. Atmospheric pressure ಎರಡು equal ಆದಾಗ, vapor pressure atmospheric pressure ಎರಡು equal ಆದಾಗ ಅವಾಗ ಏನಾಗುತ್ತೆ, liquid boil ಆಗುತ್ತೆ, and that temperature or that point is called as boiling point. Okay, the temperature at which vapor pressure of liquid becomes equal to atmospheric pressure, Vp is equal to atmospheric pressure, is called as boiling point. Boiling point. The temperature is called as boiling point of liquid. Now, what is the boiling point? Boiling point of water, H2O, boiling point is written. You have two boiling points of water. One is standard boiling point of water. Standard boiling point of water, and one more normal boiling point. Normal boiling point of water. Standard boiling point is standard boiling point at 1 bar pressure. 1 bar pressure. 1 bar pressure iddaga standard boiling point is to 99.6 degrees Celsius. Example barthidu. What is standard boiling point and what is normal boiling point? Normal boiling point of water is 100 degrees Celsius. 100 degrees Celsius at 101 325 kilopascal. Pascal pressure is measured in terms of pascal or atmospheric pressure or mmHg. So 101.325 kilopascal अथवा 1.01325 bar pressure. Okay. See here, boiling point of water. There are two types of boiling point of water. Boiling point of water one the standard boiling point and the another is normal boiling point. Standard boiling point of water is 99.6 degrees Celsius at 1 bar pressure. Pressure is 1 bar. Normal boiling point is 100 degrees Celsius at pressure is 1.01325 bar pressure अथवा 101.325 kilopascal. Okay. So what is boiling point? Boiling point of liquid. The boiling point of liquid is nothing but the temperature at which, say on heating, vapor pressure increases. The temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. Vapor pressure becomes equal to atmospheric pressure. So you have two pressures here. So this is vapor pressure. And outside here you have another atmospheric pressure. Atmospheric pressure. Okay, atmospheric pressure. Vapor pressure and atmospheric pressure yavaga same equal avaga liquid boil start agutte. So that point is called as boiling point. So it has been asked many times for one mark question. Define boiling point. What is boiling point of liquid? Athwa standard boiling point of water is अथवा normal boiling point of water is 100 degrees Celsius. Standard boiling point of water is 99.6 degrees Celsius. Okay. Now see what happens as we move at mountains. So higher altitudes. Mountains. High altitudes. Mountains or higher altitudes, pressure will be what? Pressure will be more or high. Pressure will be low. Pressure kadme irutte. So pressure kadme iddaga atmospheric pressure will be less. This is itself atmospheric pressure. Pressure enirutte kadme irutte. So obviously liquid will start boiling faster. Vega boiler. Below its boiling point. Normal boiling point boil aguttalla adukkinta kadime time alli kadime point alli boil agutte. Below its boiling temperature. Low temperature boil agutte. It boils at low temperature. When pressure is low, temperature liquid starts to boil at lower temperature. So at higher altitudes, mountains alala pressure kadme irutte. So pressure kadme idaga boiling temperature also will be less. Ika for example, outside ikkade nam kade ella water boils at 100 degrees Celsius. 100 degrees Celsius the water boil agutte. But alli altitudes high altitudes before boiling point, before this temperature only it will start boiling. And then low temperature will boil agutte. At lower pressure it will boil at low temperature. So before reaching its boiling point only it will start to boil. So at high altitude, since pressure is low, liquid boils at lower temperature. So one more important point is another important point is boiling does not happen, does not takes place in closed vessel closed vessel boiling does not happen. Boiling does not take place in closed vessel. So understood? Here vapor pressure, first property. So we have started with liquids. Liquids are those in which molecules are loosely arranged. Solids in which molecules are closely packed, loosely arranged in liquid, and in gases it is random, freely moving. Solids have definite shape, definite volume. Liquids have definite volume, no definite shape. Gases have no definite shape, no definite volume. Okay? Intermolecular force of attraction in liquid is greater than gases but lesser than solids. Intermolecular force of attraction. Due to this, liquids exhibit some of the properties such they are vapor pressure, surface tension and viscosity. Vapor pressure actually. What is vapor pressure? Vapor pressure, normally the vapors of the liquid in vapors ಮತ್ತೆ liquid ಎರಡು equilibrium ಅಲ್ಲಿ ಇರುತ್ತೆ. Equilibrium means both are in equilibrium, both are balanced. Vapors of liquid and liquid both are in equilibrium. Okay, the pressure exerted by the vapor on the surface of liquid is called as vapor pressure. Vapor pressure exerted by the vapors on the surface of liquid is called as vapor pressure. So this is also called as saturated vapor pressure. So on heating, what happens if you heat? On heating, vapor pressure increases. The temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. Vapor pressure become equal to atmospheric pressure. Is called as boiling point. Of liquid. At this point, liquid starts boiling. Okay, and there are two types of boiling point. Boiling point of water are two types. Standard boiling point, normal boiling point. Standard boiling point is 99.6, normal boiling point is 100 degrees Celsius. At 1 bar pressure, at 101.325 kilopascal, this bar pressure. Okay. If that is done, we'll move on to next concept, surface tension. See, at higher altitudes as we move, mountains ಅಲ್ಲಿ pressure ಕಡಿಮೆ ಇರುತ್ತೆ. Pressure ಕಡಿಮೆ ಇದ್ದಾಗ liquid ಬೇಗ ಬಾಯ್ಲ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, low temperature ಅಲ್ಲಿ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ. So normally ಎಲ್ಲ 100 degree Celsius ಬಾಯ್ಲ್ ಆಗುತ್ತೆ liquid ಅಂತಂದ್ರೆ ಅಲ್ಲೇ ಲಿಕ್ವಿಡ್ ಬೇಗನೆ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಕೆಳಗಡೆ ಆಸ್ ವಿ ಮೂವ್ ಡೌನ್ ಮೌಂಟೇನ್ಸ್ ಕೆಳಗೆಲ್ಲ ಬೇಗ ಬಾಯ್ಲ್ 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಬಾಯ್ಲ್ ಆದ್ರೆ ಅಲ್ಲೇ ಹೈಯರ್ ಆಲ್ಟಿಟ್ಯೂಡ್ಸ್ ಅಲ್ಲಿ 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗನೆ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ. ಲಿಕ್ವಿಡ್ ಸ್ಟಾರ್ಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್ ಫಾಸ್ಟರ್. ಓಕೆ, ದೆನ್ next one, next property, surface tension. Surface tension, this is one of the property of liquid. So what is surface tension? Surface tension. Tension means pressure, force. See, tension refers to force. Surface force. The force acting unit length. The force acting on a unit length perpendicular to the surface. The surface is. This is surface of liquid. Interface. ಸರ್ಫೇಸ್ ಅಂದ್ರೆ ಏನು ಹೇಳ್ರಿ, ಇದು ಒಂದು ಬ್ಯಾರಿಯರ್ ಇದ್ದಂಗೆ. ಇದು ಸರ್ಫೇಸ್ ಅಂತಂದ್ರೆ ಒಂದು ಬ್ಯಾರಿಯರ್, ಲಿಕ್ವಿಡ್ ಗೆ ಔಟ್ಸೈಡ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ನಡುವೆ ಇದು ಒಂದು ಬ್ಯಾರಿಯರ್ ಇದ್ದಂಗೆ, ಅದು ಸರ್ಫೇಸ್. ಇಂಟರ್ಫೇಸ್, ಬ್ಯಾರಿಯರ್ ಬಿಟ್ವೀನ್ liquid and outside atmosphere. So the force acting unit length perpendicular to the surface of liquid. So force acting per unit length perpendicular to the line drawn on the surface. See, force tension means what? Force acting on unit length perpendicular to the surface. So ಏನು force apply ಮಾಡ್ತೀವಲ್ಲ unit length, this force is called as surface tension. So it is denoted by, surface tension is denoted by this symbol. This symbol is called as gamma. Surface tension is denoted by gamma. Okay, unit of surface tension, SI unit of surface tension. SI unit of surface tension is Newton meter per meter. Newton per meter antandre it can be given as Newton upon meter. Newton is a unit of force. So SI unit of surface tension is Newton upon meter. Newton ಅಂತಂದ್ರೆ force in unit ಇದು, meter length. Okay, it is given by N upon m, so that is equal to Newton per meter. Force acting unit length, ಅದಕ್ಕೆ definition ಏನು? Force acting unit length per unit length perpendicular to the line drawn on the surface of liquid is called as surface tension. Force acting per unit length perpendicular to the line drawn on the surface of liquid is called as surface tension. It is denoted by gamma, symbol is gamma. SI unit is unit per meter, Newton per meter. Okay, denoted by gamma. Unit is Newton per meter. Newton is a unit of force in unit and meter per length. Next is surface energy. What is surface energy? Surface energy. Energy required to increase the surface area of a liquid by 1 unit is called as surface energy. Energy required to increase the surface area. Energy required to increase surface area of a liquid by 1 unit is called as surface energy. It is denoted by unit is SI unit is joules per meter square. Joules per meter square. So it can be written as joules upon meter square. Joules is a unit of energy. Energy unit is per length square. Okay, so energy required to increase the surface area of a liquid by 1 unit is called as surface energy. So unit is joules per meter square. ಈಗ ಇದನ್ನ ಎಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ? Where do you see is because of this surface energy minimize ಮಾಡೋದಕ್ಕೆ most of the raindrops, if you see raindrops are spherical in shape. Irutte drops. So drops are raindrops. Raindrops are spherical in shape. Why? Because to minimize the minimize spherical shape in ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ spherical shape provides minimum surface area. Spherical shape provides minimum surface area. ಜಾಸ್ತಿ surface area ಬೇಕಾಗಲ್ಲ ಅದಕ್ಕೆ. Minimum surface area. ಅದಕ್ಕೋಸ್ಕರ raindrops are spherical in shape. Then mercury drops are spherical in shape. Mercury ನೋಡಿರಿ, mercury Hg. Mercury drops spherical round ಈ ತರ ಇರುತ್ತೆ. silver color mercury. So mercury drops are spherical in shape. Raindrops are spherical in shape. ಈಗ glass window panels ಇರುತ್ತಲ್ಲ, window glass ಇದು heat ಮಾಡ್ತಾರೆ glass ನ. ಯಾವಾಗಲೂ super cooled liquid ಅಂತೀವಿ glass is a super cooled liquid. So this glass, what happens is after cooling it is a slow cooled. Glass is a slow super cooled liquid. Glass is super cooled liquid. So actually what happens, if you see at the edge of the glass you can see spherical shape. Bulges ಇರುತ್ತೆ, ಈ ತರ bulges ಇರುತ್ತೆ. Carefully observe ಮಾಡಿ ಅಂತಂದ್ರೆ ಇದು spherical shape bulge ಆಗಿರುತ್ತೆ, ಈ ತರ ಉಬ್ಬಿರುತ್ತೆ. Because after cooling ಇದೆಲ್ಲ ಕೂಲ್ ಆದ್ಮೇಲೆ ಲಿಕ್ವಿಡ್ ಹೆಂಗಾಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಈ ತರ bulge ಆಗುತ್ತೆ, ಈ ತರ flow liquid will flow. So that is why you can see glass edges are bulged like this. ಈ ತರ bulges ಇರುತ್ತೆ, flow ಆಗುತ್ತೆ, liquid flow ಆಗಿ ಈ ತರ bulges ಆಗಿರುತ್ತೆ. So that is again to minimize the surface area. Okay, so this was about surface tension, surface energy. and vapor pressure. Next is viscosity. What is viscosity? What is its unit? Third property, viscosity. Viscosity. It is the resistance, it is a measure of resistance to the flow of liquid. It is measure of resistance to the flow of liquids. It is the measure of resistance to the flow of liquid. For example, if you take two slides here, glass slides. Here glass slides ತೊಗೊಂತೀರಿ. Okay, on one glass slide you are adding pouring water. Water na pour ಮಾಡ್ರಿ. ಇನ್ನೊಂದು glass slide ಮೇಲೆ honey, pour honey. Okay. So what you have to do is you take the two glass sheets. ಎರಡು ಗ್ಲಾಸ್ ಶೀಟ್ಸ್ ತಗೋರಿ, ಸ್ಲಾಂಟಿಂಗ್ ಪೊಸಿಷನ್ ಇಡ್ರಿ. ಒಂದು ಗ್ಲಾಸ್ ಶೀಟ್ ಮೇಲೆ ವಾಟರ್ ನ ಪೋರ್ ಮಾಡಿ. Okay, you see how fast it is moving. Okay, take another glass sheet, pour honey. ಎರಡು ಒಟ್ಟಿಗೆ ಮಾಡಿ, simultaneously ಮಾಡಿ. Okay, which one will reach fast? Which one will move fast? So take a glass sheet, one glass sheet, second. Here you are pouring water, pour water, and here you pour honey. Okay, time 0 time to both. Yav first drain ag barth, which one will flow first? Yav flow agutte first? So which will flow first? Water flows first. Water, then honey. Why? Yakantandre here the resistance. So one layer inda ಇಲ್ಲಿ resistance ಜಾಸ್ತಿ ಇರುತ್ತೆ. It is resisted here more. So flow ಆಗೋದಕ್ಕೆ ಕೊಡೋದಿಲ್ಲ. One layer ಇಂದ ಇನ್ನೊಂದು layer. Friction is more here. Instead of that, it is friction. Friction is more. Friction. In case of honey, friction is more. So that is why it will not flow freely. But whereas in water it will flow freely because of friction is less. Resistance is less here. Why here resistance is less and why it is more here? Again, this is because of intermolecular forces. Intermolecular forces of attraction. In water, intermolecular force of attraction is lesser, whereas in honey, intermolecular force of attraction is greater. So intermolecular force of attraction ಜಾಸ್ತಿ ಇದ್ದ ಏನು ಮಾಡುತ್ತೆ ಅದು? So molecule does not allow, resist ಮಾಡುತ್ತೆ. Free flowing ಗೆ resist ಮಾಡುತ್ತೆ. So intermolecular force of attraction holds them together. Molecules ಎಲ್ಲ they hold them together. They will hold them together. Intermolecular force of attraction is greater here, lesser here. Honey ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, water ಅಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ. So ಹಾಗಾಗಿ friction ಜಾಸ್ತಿ ಇರುತ್ತೆ. Friction, resistance ಜಾಸ್ತಿ ಇರುತ್ತೆ, whereas here it is less. So the measure of resistance to the flow of liquid is called as viscosity, and this depends upon area. So this force depends upon area. So whatever force is there, that depends upon area. Therefore you can write it as force is directly proportional to area. Okay, so this you can write it as area is nothing but you can take this area as du upon dt. Du upon dt and what is du upon dt? Du ಅಂತಂದ್ರೆ difference in velocity, difference in velocity between adjacent layers. Okay, difference in velocity. Difference in velocity. It is called as difference in velocity between two layers. Difference in velocity is taken as du upon dt. Okay, so what is force is directly proportional to A and area, that is nothing but du upon dt. So proportionality constant tagre you get a here. A is a constant into A du upon dt. Rate of velocity. This is called as rate of velocity between two layers. It is called as rate of velocity. Rate of velocity between the layers. ಎರಡು ಲೇಯರ್ ನಡುವೆ ಏನು ವೆಲಾಸಿಟಿ ಇರುತ್ತಲ್ಲ, ಸೊ ಬಿಟ್ವೀನ್ ದ ಲೇಯರ್ಸ್, ಫಸ್ಟ್ ಲೇಯರ್, ಸೆಕೆಂಡ್ ಲೇಯರ್, ಥರ್ಡ್ ಲೇಯರ್. So differences in the rate, velocity differences between the layers is given by du upon dt. So therefore A is equal to A ಅಂದ್ರೆ ಏನು? Proportionality constant. A is a proportionality constant. So that is given as A is nothing but proportionality constant. It is called as coefficient of viscosity. Coefficient of viscosity, which is given as nu. Whereas nu is coefficient of velocity. Okay, so velocity, viscosity, coefficient of viscosity. Viscosity, what is the unit of viscosity? Unit of viscosity is viscosity coefficient. Coefficient of viscosity is given by nu. Itra symbol. Okay, so this is equal to, the SI unit of this is Pascal second. SI unit is Pascal second. Pascal second. SI unit is Pascal second. Okay, so with this we have completed viscosity, surface tension, and the properties. Three properties of liquid. They are, see, vapor pressure, surface tension, and viscosity. So what is vapor pressure? The pressure exerted on the liquid by the vapor is called as vapor pressure. The pressure exerted by the vapors on the surface area is called as vapor pressure. Surface tension antandre it is a force. Tension means force acting unit length perpendicular to surface. What is viscosity? It is the measure of resistance. Resist ಮಾಡುತ್ತೆ. Resistance to the flow of liquid is called as viscosity. Okay, SI unit of vapor pressure is SI unit of vapor pressure is, so where are it in SI unit? Vapor pressure Vapor pressure we have not written, I think, right? So surface tension SI unit is Newton per meter, and energy is surface energy joules per meter square, and viscosity coefficient unit is Pascal second. Pascal second is the unit of coefficient of viscosity. So definition note kore, unit note kore. You have to see definition and unit. All these three. More the definition of the unit. But what is normal boiling point and what is standard boiling point and what is boiling point of liquid. So these are the questions asked on this concept. So next class will be continuing with last part of states of matter, liquefaction of gases. So any doubt?